Hi, everyone. Um, so I guess today let's give people a few more minutes to join in. Hey, Jeff, if we wanted to have a gathering during the OFC, do you have any suggestion about the
I'm sorry.
times or?
I'm sorry, Bobby. I didn't hear the first part of the question.
Oh, oh, that's good. I was saying that if we would like to get together, have a uh quick get together on in during the OFC. Do you have any suggestion about the times or time slot or uh,
Oh, wait, let me look at the calendar for that week. So I think last year or somewhere did we do a breakfast one time?
yeah,
Or
when we were in the ECOC and we did at breakfast time, and
oh,
so I don't think I participated the OFC one last year, so
oh,
I don't exactly know uh, the kind of like the tradition of the OFC get together.
right, right. And no, I don't have any suggestion
Yeah, because I think this year is different places and kind of a different schedule. So I don't know
really.
if people will prefer in the morning or afternoon after the
Well, I think doing it either before the show floor opens, in the 8 to 10 region, or after it closes, say 5 to 6. That those would seem to be days. And I'm thinking that by the time you got to Thursday, if we did it like Thursday morning, like I think we did it one of the last times, then most of the things people have to do are over.
yeah. Um, okay, so I think we well that's a good suggestion. So I think um I'll I'll check I'll probably um still doing with the morning, like you suggest, and then before the show floor time, and uh, I'll arrange something and then send to everyone.
Okay, that sounds good.
So looks like today is gonna be a light one, and one things I like to share to everyone is this presentation from Bijan shared with me. I think it's interesting, and I don't know if people already seen this before, but uh, I think it's a we can discuss it together to see um, the uh, how did impact to our target white paper and what would be do we have a chance to create something uh, our version of it. So this is the IEEE simulation, um, and it's the about the 400G in the simulation. And of course, when we said we're targeting the UA link, which is the current spec that's supposed to come out at the end of this month, is using the 200G as a standard. But it's good to forecast something in the future. especially as Karen's presentation pointed out, 200G could be a pivot point. And so for between the optics and the copper in the short distance, so 400G would be probably more close to the optic side. And so this this simulation actually caught my eye because um, because um, I think the 400G, although the modulator is not that mature at the moment, the driver is, of course, people are still working on it yet, but a lot of it that we can simulate with it, especially 200G, people will still stay as PEM4, and what would be the 400G? Should we stay with PEM4 or should we go with PEM6? And is there gonna limit some of the application in that level? For example, the there's a multi-mode fibers that gonna limit the amount of distance that transmitting due to the dispersion. So I think that would be an interesting things that all of us would be able to contribute into the study, and of course the white paper will recognize each of the people who contribute people and company to contribute into the overall white paper. So as you can read it here, they're trying to working on the simulation, and these are the setup default. And
Bobby,
so
sorry. I
yeah.
have a really quick and dumb question. So I come from the electrical background. So I understand that if electrical go PAM6, that may cause some issue on the optical side, as the previous slide mentioned. But is it
Yeah.
possible during the electrical to optical conversion and vice versa, electrical use PAM6, but optical stay PAM4?
So this is the key part, right? I think unless you want to design two different drivers, because the optics obviously still need a driver to modulate the optical component. So that means you have to somehow convert the PEM6 into PEM4. And this additional conversion, that means you have to burn additional power, especially that in a short distance, people are concerning about the power. That's why people wanted the linear drive, and that means the optic is going to be drive directly from the optical electrical phi.
I
So
understand. Okay.
so that's why it's preferred to stay the same.
Sure. Thank you.
No, I think this is kind of clear it up. It's actually the purpose of this study. I think I probably go too fast in here because as you can see in here, it kind of mentioned in here there's a benefit for the same modulation format for electrical and optical sublink. So at least for low loss or low power or something like that. So it's actually they states in here the reason why you want to using the same the same modulation and for electrical and optics. And of course, well, I'm also wondering for because the optics is some of the conversion is not that linear compared with the the copper loss. So uh, so in the media, for optics has many different versions, because we also have the DML, EML, or the VCSEL, even people who working on LED might have a totally different idea about these things. So that's why I think it worth a while to view it. Sorry. Harden, you raise your hand. If you have any things you'd like to
Yes,
share
thank
with?
you. I would like to make a comment on PAM4 and PAM6.
Yes.
So we've done some experiment at Keysight, and also we are monitoring what the industry is doing. So obviously the PAM6 is very attractive for electrical interface because of the channel requirements. It requires less bandwidth, and it's easier for the electrical guys to design channels that are 80 gigahertz of offer 80 gigahertz of bandwidth rather than 110 or 120 gigahertz of bandwidth. So, and the question why I wanted to react is the question, why don't we use PAM6 in optical then? Then it would allow to not to use a retimer in between or a gearbox, which is expensive and power hungry and so on. The problem of PAM6 is that it has a higher SNR penalty compared to PAM4, and
Yes.
optical links are usually more noisy. You have, after the photodiode and so on, you have a relatively noisy signal. And this is why optical people or optical designer prefer to continue to use PAM4. They don't have this bandwidth limitation that we have in electrical channel, but they have more stringent SNR requirements. Yeah, so this is my comments, and obviously it would be good to avoid the usage of a gearbox in between, but it seems that they are very hard trade-off to meet to achieve this.
I think you pointed out the key things, because that I think that's what we, this work group like to addressing on is, for the future design, especially this kind of a short distance, but it's actually not that short. For 400G, if you try to go with copper, and the amount of distance that you can travel is possibly less than a meter, and people might go with like a different phases, doing multi the the different phases in the design, instead of the PAM modulation to one wire for 400G. And so but for optics, driving for the fiber traveling for 100G is totally okay. And so that's why we would like to study the trade-off, and especially how the packaging, how to put it close together to like I said, to minimizing the conversion, minimizing the gearbox, to eventually lower down the power and cost altogether. I think that's what we'd like to address in here. And so this simulation kind of try to show that. As you can see in here, they simulated with a conversion and the modulator in here, and there's all the link as a PIN receiver. There's a limitation in here. It's 25 picoamps per hertz. I think it's a reasonable setup. And then there's some additional equalization at the end, right? So this is a pretty good initial simulation setup. The prefect BER is 4.8 e to the minus 3. This is good for Ethernet level, but as a short distance optics, and especially we are in this kind of a scale up network, is really critical for the optical for the latency consideration. And so when you're adding more effect, it's usually equal to longer latency. So how does the overall things that we can improve or we can consider from a system point of view? You have to cover the amount of latency, cover the distance, and is there a good trade-off in between? And I think we should work as a team together to come out with a simulation for that. So in here, as you can see, the PAM4 simulation, the for a reasonable, for example, the PCIe is targeting 10 to the minus 6, or usually at the PAM4 level, to have a very light fact, your 10 to the minus 6 or 10 to the minus 8. If you cross it over to look at that, even at totally no dispersion, you still require certain amount of energy per channel, which is like -2 dBm per channel, and that seems not a small number, because that means your single laser energy comes out with all the losses during the packaging, the stacking, alignments, adds up. Each laser can only maybe share with one or two channel. So that means you're burning a lot more power in the laser at the point, but it seems okay. But compare with the PAM6, as you can see, for similar results, it actually requires a way higher power in the requirement. For the lower FAC, a higher, stronger FAC, it seems doable. But for our near distance requirement, which is a latency sensitive, seems like the power will be a big concern in here. So that's I think we can look at it a little bit more in here. If you have the this is 113, which is the 200G, and then this is 400G, 400G. Then the power is almost like a 10 dBm for the same requirement, which is possible. And for the PAM6, then that is it's almost nearly impossible to reach the to use the same fact, which is a very light fact, the flip mode, to transmitting the low latency data in a short range. Everything requires a pretty strong spec in here. So so I don't know if people have seen this presentation before. If you're in the IEEE working group, you probably have a chance to do it. If not, then I can kind of share these in the team, so we can all view it and having some discussion about it. So the key things, one of the key things in here is, for example, we're actually the application for us is way less than 500 meter in here, 500 meter support, and we can do way less than that. We can set the things way less than that, but is there when we are less than 500, does it relax some of the limitation on the laser, since the fiber dispersion is not that big, but does that relax some of the things on the laser? And I think these are the design challenge for the driver, the timing, and then so let's look at the conclusion in here. So as you can see, the the reason that support for PAM4 is just they have a better signal to noise ratio, and so that kind of reduce the amount of the nature disadvantage for the optics, and also it's but PAM6 is probably easier on the circuit design, and so I would like to hear what people think about this, and wonder if anyone could be able to volunteer working on some simulation, specifically targeted in the extremely short range, short reach, something like lesser than 100 meter or 50 meter, and does that relax any kinds of design criteria, especially in the PAM4, or because that means the PAM6 is possible in this kind of range.
So, Bobby, you're focused primarily on 400G then?
No, I think this is I think I was kind of picturing the short reach white paper will have the UA link, and we will target it for we will have something for existing 200G, using the 200G or 100G, you know, because the 100G is a fallback for UA link, and to list out all the possible solutions and pros and cons for that, and then we maybe have one last chapter just to forecast, you know, if anything goes to 400G as the next generation. What would that what would that be? You know, is there anything that we should concern about 400G? And that would be the things that I had in my mind.
Okay. Thanks.
Harun?
Yes. Okay. So, so I understand your request and why and our objectives. To my understanding, the main challenges for deploying 400G, whether PAM4 or PAM6, is on the switch side, also on the host side. So how long is the electrical channel we have, what kind of electrical channel, and so on. So is it so this is the main limitation, because this is what limits basically the modulation that will drive your modulator. And then also the question, are we looking at the linear devices, so where the switch is driving the module directly, or are we considering retime optics when we could have a gearbox, and so on and so on. So this, what I'm trying to say is maybe it would be good to define some kind of scenarios before we are looking into this.
Yes, I totally agree. I think I can. That'll be good. I think I can draft. I can maybe draft something, because as you mentioned about the electrical path that in between is a critical part for the simulation, and that is the that is a part that I think we can. That is a part that actually would convert into the optics. Is, you know, does the people still wanted to do on panel pluggable, or this would be the time that people wanted to switch to a near package optics?
But my point was, maybe before we start kicking off this kind of simulation and in-depth investigation, that we agree on a larger framework, right? And that we have maybe a common session when we decide, okay, this is a kind of scenario. Maybe we define 1, 2, 3, or 4, whatever, what we want to have a look. Is it a PCB trace? Is it retime, non-retime? Do we have, what kind of requirements we have on the electrical side, and then we can move on. And
yes, that's actually a very good suggestion. I will. I think we can.
If I could just just to say something. So I understand where Adrian's coming from. The view that I take is that different system designs are going to do it differently. Some people will find it advantageous to do co-packaging. Others will want to use pluggables. There's pros and cons with each approach, and affects the power consumption, you know, whether it has to be retime transmit linear receiver, or, you know, fully linear, those kinds of things. I think in the white paper, what would be good would be to show the range of solutions, and just say and describe what the penalties are. You know, if you do this, this is what you have to have. That's the way I think of it.
Yes.
yeah, this is fair. This is the other way around is also okay. Yes.
So I don't know, Bobby, you know, I could send out, there's a chart. I think I showed it to the group before, which is insertion loss versus energy utilization. It's sort of a more generic plot, but it helps to illustrate, I think, the, you know, the issue. And you know, maybe that's a good way to go back and think about it. Do you remember that chart?
Yes, I do remember that you shared it with a group before, and I don't, but I think you still continuously adding more data points into that chart, right? So we probably don't have the latest one.
Yeah, it hasn't changed too much. That particular one hasn't changed too much. But yeah, so anyway, that's just to let you know that I think it's a good idea. Just to understand, because you know, nothing comes for free. So.
Right. And I think it's that, yeah, that's totally true. And we, as Hadrian suggests, I think maybe we should we should pick certain distance, or you know, several scenario, or I don't know. I'm still trying to drafting around it, because one things I'm actually waiting for is when UA Link actually publish the 1.0 spec, then we can we can have a better framework to follow with for the study, and then we can kind of plan out with several scenario uh, based on their spec, and then work on it. I'd also try to reach out the UA Link consortium, ask them to help us on some of the uh, the challenge that in what they like to see in the future, in the optical side, you know, in their system design challenge, and share with us. So hopefully, in the next couple weeks, we'll be able to get something from them.
Hey, Bobby, I recently did a summary for my own company, summarizing the 400G workshop right before DesignCon. So Senior, they host a 400G workshop, and I got 5 presentations from Synopsys, Cadence, no Cadence, Synopsys, Meta, yada. And I did a summary for my own company. From electrical side, I can clean up and shorten that presentation and show it here next week. That may give some really high level picture, but mostly from the electrical side, by the way, what the system may look like and what the solution may look like, starting from 200 going to 400. If that is interesting to people.
I think it's definitely interesting to the people, to the audience in here. If you are able to do that, please,
Yeah.
please, you know, whenever you're ready, let me know, and we can schedule time to.
Oh, next week will be fine. It won't take me long.
Oh, okay. Yeah, that wonderful. Thank you.
And by the way, one more point about UA Link. I do have access to the 1.0 release candidate. The electrical is more or less just one line, say that 802.3 DJ, that's the spec they are following for the electrical. I don't know the protocol side or anything that may be relevant, but if it's not as relevant as the electrical, we can really just look at the 802.3 DJ.
I would like to add something here. Yes, Raymond, and especially they are leveraging the DJ, KR, and CR, which is interesting. They are not leveraging the chip to module interface. So far, they just mentioned CR and KR, which to me tends to a purely electrical interface or kind of linear interface.
Yeah, but the UA Link 1.0 is only 200G, right? So
Yeah, but it's not chip to module. This was my point. They mentioned a they mentioned only KR and CR interface for the 200G. So I'm not sure if because they didn't have the time or the resource to look into the chip to module interface, or whether they really decided on purpose only to look at this kind of backplane and passive copper interfaces. But we can discuss this in another meeting. It was also a surprise to me.
Yeah. Right. I think there's many things that we can discuss in the future. So I mean we're a little bit over time. And thank you, Raymond, for willing to share next week. So thank you, everyone. If you have any idea or thoughts, don't hesitate to shoot me the email. We'll see you next week.
Bye-bye.
Bye.
thank you. Bye bye.